So today we're talking about rational functions. We're talking about functions that have a ratio or a fraction in them. And we're talking about the asymptotes specifically. So we'll learn how to kind of graph some of these with asymptotes. So this is one you should be familiar with. It's the parent graph we just learned about. I just want to mention something. So it does have a vertical asymptote here at always label the equation x equals 0. So it doesn't have an actual y-intercept, right, in this case. And that's because uh, what value for x would make the denominator equal 0? Well, x equals 0, right? X, you can't, 1 divided by 0 is undefined. So it causes this vertical asymptote in the graph when you divide by 0. That's really the cause of it. So you can almost look at the denominator, okay, that's where the vertical asymptote. We'll learn about the horizontal asymptote this lesson, why there is a horizontal asymptote at y equals 0 for this particular function. You remember the graph, it looks something like this. First quadrant, third quadrant, and you got it. Okay, so let's look at a few examples. So we're going to start with vertical asymptotes. Again, I want you to look at the denominator to find the vertical asymptote. So think of that. Don't butcher that, and you can't cancel anything there. There's nothing that cancels. That fraction bar is like a grouping symbol, so put parentheses around those right away. You want to look at that denominator. Set the denominator equal to 0, so x minus 2 equals 0. We're just going to solve that and get x equals 2. So that actually is the equation of our vertical asymptote. So we'd start graphing this. The first thing we would do is go, okay, we've got to graph the vertical asymptote. So x equals 2 is the equation of our vertical asymptote because the denominator cannot be equal to 2 or be the x can't be equal to 2 or the denominator be equal to 0, basically, right? So that's going to cause our vertical asymptotes. Vertical asymptotes are pretty quick to find. Nothing cancels here, so there's going to be a vertical asymptote wherever that denominator is equal to 0, which of course would be x equals -1 would be our va here. So sometimes I use abbreviations. So va means vertical asymptote at x equals -1. Always, always, always use the equation of that. And so right away, the first thing you do in this graph is you go, okay, I'm going to graph this. I graph the vertical asymptote at x equals -1. Just label that equation x equals -1. And then we go about graphing. So that's how you do vertical asymptote. Well, let's take a couple other situations. So we're looking at two other situations here. So let's look at these two. Ooh, okay. So this is interesting. So it is possible to have two vertical asymptotes. But when this unique situation happens, when you cancel, so if you cancel, you're going to get a hole. So a hole is like an ordered pair. In this case, you can tell that the x value of the ordered pair is -2. My new function would be y equals 1 over x minus 3, right? That's my new function after I cancel it out. And so to find the y value of the hole, you're actually going to plug in a 2 for x. That's your x. So plug in a 2 right there. So 1 over -2 minus 3 is -1/5. So -1/5 is my y value there. And I found the value of that hole here. So let's kind of sketch this out. And let's start with that hole here. So let's put the hole at the ordered pair -2, comma. So right about, it's hard to say, but right about right there at -2, comma, -1/5. There's a little tiny hole in the graph right there. I put a little open circle, indicate the graph's going to go through there. Unlike an asymptote, it's going to kind of go through there in the process of graphing. Okay, so x minus 3. So we have a va vertical asymptote at x equals 3. That comes from this causes a vertical asymptote. It doesn't cancel. It's in the denominator, so x can't be 3. So we have a vertical asymptote at x equals 3. So there is a vertical asymptote for this graph, x equals 3. So there are 2 points of discontinuity in this graph. One at x equals -2 and one at x equals 3. but they have totally different behaviors here. We'll see that in just a minute once we come back to this one. So this one, before you do anything, I might consider just kind of factoring this. If it can factor, the numerator doesn't really factor, so I'm just going to leave that the way it is. But it'll definitely help us to factor the denominator. Hopefully you see it, x plus 2, x minus 2. So let's graph our graph. It looks to me like it's going to have two vertical asymptotes because neither one cancels, so they're definitely both vertical asymptotes. There's going to be vertical asymptote at x equals 2. That comes from this one. And x equals negative 2. That comes from this one. So x equals 2. And a dotted line at x equals negative 2. It's where the graph is not going to touch because it's undefined there. The denominator would be 0 at either of those two values. Okay, so the vertical asymptotes come from the holes. Be careful if a hole vertical asymptotes come from the denominator. If a factor cancels, it causes a hole. So that's just like a little pinprick of the graph. We'll get to that in just a minute. So the three cases for horizontal asymptotes. That's a horizontal dotted line like we had on 1 over x. So if the degree is bottom heavy, what I mean by that is this. So let's say you have something like this, y equals x plus 1, which is an example problem, over x minus 2 times x plus 3. You can see that the denominator has a degree of 2. X times x is x squared. The numerator has a degree of 1. So this is a bottom heavy degree. So when the degree is bottom heavy, it always has the same horizontal asymptote. So the ha will be at y equals 0, always. In fact, like if you look at the one we know, our parent graph, 1 over x, the degree of the numerator is 0, the degree of the denominator is 1, and so that one has a horizontal asymptote at y equals 0. Top-heavy degree, here's just an example of what that might look like. So say you have x squared minus 2 up top divided by x plus 3 in the denominator. So the degree in the numerator is 2, degree in the denominator is 1. So this is top-heavy, which means there is absolutely no horizontal asymptote. Third situation is you have the same degree. So let's say you have something like this. Y equals 2x squared plus 5x over 6x squared minus 1. So if this is the case, you do have a ha. For the ha, you divide the coefficients. Maybe I should say it this way, the lead coefficients. So in this case, the numbers in front of the largest term, x squared, are 2 and 6. So you'd have y equals 2 over 6, or 1/3 would be your horizontal asymptote for this example. But you divide the leading coefficients, whatever the two leading coefficients are, you're going to divide them. That will be your horizontal asymptote. Okay, getting back to these that we already did let's just go back to them. I've got them on the other page here. So here we go. So let's find the horizontal asymptotes. I'm going to do these in red here. So what's the case here? So is this top heavy, bottom heavy, or same? So this is same, right? X to the first over x to the first. The coefficients are 1 and 1. So you're going to have a ha at y equals 1. Okay, so let's draw that. So y equals 1. And let's go ahead and go next steps here. So, let's just find the asymptotes and then we'll go from there. We'll come back to these. Okay. So let's just go through all the asymptotes. So this is top heavy, x squared over x. So there's no ha. Oh, that's tough. It's not very nice when they don't have a horizontal asymptote. This one is bottom heavy, so 1 over x minus 3. So that's bottom heavy. So there is going to be 1 at y equals 0, whenever it's bottom heavy. So y equals 0. And this one is same degree, so I'm going to divide the coefficients. So there's going to be a ha at y equals 3/2, which is 1.5. So right about here, at y equals 3/2 or 1.5 is my ha. Okay, so let's see what the next steps are. So let's go back to this. Okay, so let me go to kind of a blank screen for a second and explain the steps to graph, to sketch. So this is the steps to sketch a graph. So first, sketch all your vertical asymptotes and holes. We've done that. Second step, graph your horizontal asymptotes, if there are any. Step 3, you're going to find your intercepts. And to do that, let me just kind of highlight that. So to find the y-intercept, plug in x equals 0. To find the x-intercept, that's an x, plug in y equals 0 and solve. So you'll find the intercepts, and then step 4 will be to sketch the graph. You may have to plug in points. Plug in a point or two, not very many. Sometimes you don't have to. So we'll get to that step here in a second. So let's find the intercepts here. So let's see if we can do that. Okay, so I'm going to do intercepts here. So to find the y-intercept, we're going to plug in x equals 0, right? So this will be y equals 0 plus 1 over 0 minus 2, which is negative 1/2. Okay, y equals negative 1/2. The graph definitely goes through that point right there. So that's the y-axis there. To find the x-intercept, we're going to plug in y equals 0. So we get 0 equals x plus 1. That's a plus there. Divided by x minus 2. It's a minus. To solve, we're going to multiply by x minus 2 on both sides. Multiply by x minus 2. And 0 times anything is 0, so that's just going to go away. On the right-hand side, you have x plus 1. So we have x equals negative 1. So it looks like there's an x-intercept at negative 1 right there. That's the only two spots the graph can cross the x-axis here. Let me go back to this page here for a second. So when we're sketching a graph, oftentimes we're going to end up with, they're not really an axis, but oftentimes you have like one vertical asymptote and maybe one horizontal asymptote. So given that kind of common situation, there's two options on the left-hand side. What I mean by that is on the left-hand side, to the left of wherever that vertical asymptote is, the graph is either going to be kind of contained in those asymptotes, like either look kind of like this, or the graph looks kind of contained and it looks kind of like that. Those are the two options. So I just don't know what quadrant. Kind of like we had with the parent function, it was down there in the third quadrant, right? Kind of thing. So it's going to be kind of one of those. It can't be both because otherwise it would not be a function. On the right, the graph is either going to look like this or look like this, right? Those are the two options, but it can't be both because, again, it won't be a function. So either it's up top or down low on the right, up top or down low on the left. So kind of keeping that in mind here. Let's go back to what we have. Okay, so here, the two options are the red and blue lines are kind of like your axes there. So either the graph kind of does this or the graph kind of does this. And I hope it's obvious to you. It's got to go through those X and Y intercepts. So it's got to be this one right here. So it's kind of contained within the bottom left quadrant of the asymptotes. I don't mean of the actual quadrant, but kind of where those asymptotes are. Now on the right, there's two options. Either the graph is like this, or the graph is like this, one of those two. Which one is it? We don't have to plug in points here because if it was the graph on the bottom there, it would have to cross through the x-axis at some point. Well, we already did a test for that. It doesn't cross through the x-axis at all, so that's the graph right there. So that's a sketch of the graph, basically. If you look at the actual graph, I think I have it over here. Here's a picture of the actual graph. Let's see how close we got. So this is the actual graph. That's pretty good. I mean, for our sketch, for not plotting any points, it's pretty solid. That's what we want. It's a solid sketch. Now this one's going to be tough right away just because we don't have a horizontal asymptote. That really helps us guide our graph. But let's find the intercepts and kind of see what's going on here. So let's find the intercepts of this graph. So let me get a different color here. So we've got the y-intercept will be to find the y-intercept. You're going to plug in x is 0, right? So y equals, this would be 2. 0 plus 2, 0 minus 3 is -3, and then 0 plus 1 is 1, so that'd be -6. Wow, okay, so I'm going to make these a little more so. Okay, so I'm going to plot the point there at -6, so it's got to go through that point right there. That's nice. Okay, to find the x-intercept, we're going to plug in y equals 0. Really, the denominator is going to go away every time, so it's going to be 0 equals x plus 2 times x minus 3. This is already factored for us. So the solutions are x equals -2 and x equals 3. So let me graph those here. Okay, x equals -2 right about there. X equals 3 right there. So on the right side, I have a pretty good idea what's happening here. So it looks like, I mean, these two lines are connected, right? I know that. These 2 points, they're intercepts. So it looks like the graph's going to be approaching the asymptote there. So that blue line, keeps on going. It's going to approach the asymptote there. And on the right, it looks like it's, well, looks like it's going up and to the right. I'm not sure exactly, but that's a pretty good sketch right there. So that's good so far. On the left, there's really two options. Either the graph kind of approaches the asymptote up on the right, or the graph approaches the asymptote down and kind of maybe does something like this. It can't approach the asymptote both directions, so that doesn't work like that. But it's got to kind of come from one direction or another. So in this case, it is good to plug in a point. So let's plug in maybe x equals -3. So if we do that, the y value would be, let's see, -3 plus 2 is -1. -3 minus 3 is -6. And -3 plus 1 is -2. So that would be +6 divided by -2 is -3, I think. So -3, -3. The big key I want you to see there is this point is down below. So this graph is definitely going up and approaching the asymptote there. It's doing something like that down there. Again, we're not really sure exactly on this one. Let's see how close we came. I think I have a picture of it. There it is. So you can see it's approaching asymptote there up top and then down low from the right-hand side. That's actually a pretty solid sketch we have. Okay, let's go back to this one. These are some tough, challenging problems here, some of these. We're spending like 2 days on this just because it's some pretty challenging stuff. So let's get rid of that so we have some room to work here. So So let's find the y-intercept. So y equals, I'm going to plug in 0 for x, so that'd be 2 over -3 times 2. So that cancels, you get 1 over -3. So y equals -1/3, right about there. Graph somewhere around there. And let's see if there's an x-intercept. So you plug in y equals 0. The denominator is going to go away, so it's just going to be x plus 2. So x equals -2. So x equals -2. Oh, I forgot. Really plug into this one, right? Because we've already dealt with the hole here. So there's not really a vertical asymptote there. There's a hole there. So it is going to go through that point there. But it's going to hop over that point. So you can probably see on the left what's happening, right? The graph's going to kind of approach the asymptote. It's going to hit that point, kind of hop over it, go through that y-intercept, and come down. So there is a little tiny pinprick in that graph there. And then here on the right, the question is it going to do that or is it going to do that? And I don't really know. In this case, I really need to plug in 1 point just to see. So let's plug in 1, 2, 3, 4. Let's plug in 4. So if x equals 4, what does y equal? So let's see. That'll be 6 over 1 times 6, which is 1. So the key thing when I plugged in 1, I got a positive number, so I know the graph, and you might have kind of guessed that is going to be up there. See how we did? I think I have it over here. Oh, maybe I don't have it. Thought I had it covered up. Well, it was pretty good sketch, trust me. Okay, and we go to the last one here. Again, this is challenging stuff for sure. So let's plug in x equals 0, so y-intercept would be 3 times 0 minus 4 is -4 over, would be -4 times 2 is -8, which is 1/2. So it looks like I have a point right there. To find the x-intercept, we're going to plug in y equals 0, 3, just the denominator goes away, 3x squared minus 4, so 3x squared equals +4, so x squared equals 4/3. So the square root of both sides, we get plus or minus square root of 4/3. I'm just going to use my calculator for a second. So square root of 4/3 is 1.15. So approximately, the reason I write that way is because I'm trying to graph this. So and you can probably see what's happening in this middle section. It looks like an upside down U is going to be contained by these asymptotes. So it looks kind of like that. And on the right, the graph either goes up top or down low, but it's got to be up top. Hopefully you see that because it doesn't cross through this x-axis at all. So it's got to be up there. The left, it either goes there or down below, but it doesn't cross through the x-axis. So it's really got to be up top like that. So we've got our graph. Wow, those were 4 tough graphs here. So we're spending a couple days on this just because it's, again, a pretty challenging topic. Let's look at a couple more here. I know it's kind of a longer lesson, but let's see if we can put it all together in one problem here, just kind of take care of business. Okay, so first let's find the nothing cancels. So there's going to be a vertical asymptote at x equals -2. So x equals -2. It's x squared divided by x squared. So because this is actually x squared, so the coefficients are the same. So 1 divided by 1. So there's going to be a horizontal asymptote. at y equals 1, because it's the same degree. Okay, find the intercepts. So to find the y-intercept, we're going to plug in x equals 0. So that'd be 1 times negative 3 over 2 squared, which is 4. So negative 3/4. So right about there. To find the y-intercept, plug in y equals 0, get rid of the denominators. That's already factored for us. So this leaves our x equals negative 1, x equals 3. So 1, 2, 3. There we go. And x equals negative 1. Oh, this is so nice. It's almost easy, right? So on the bottom right, it's got to go through those 2 points. So the graph has to look kind of like that. It's got to go through this point. So on the left, the graph has to look kind of like this. So that may be surprising to you. It's not always in kind of opposite quadrants there. So in that case, it has to go through those intercepts. So it's got to look like that. I didn't have to plug in any points, and we got it just perfectly. This one, I know you've done this with transformations. You know it probably goes to the right 2 units. But if we do it this new way of thinking, we're going to go, well, the vertical asymptote is x equals 2. X equals 2. Horizontal asymptote is y equals 0, because it's bottom heavy. The intercepts will be y equals 1 over negative 2, so negative 1/2. And the x-intercept 0 equals 1, because the denominator goes away. Well, that's not true. It doesn't really have an x-intercept. So you can tell it definitely goes through that point. So it's kind of looking on the bottom there. I don't really know on the right. It could be up top or down low because of the intercept. It doesn't tell me enough. So let's plug in a point like x equals 3 and see what happens. So we get y equals 1 over 3 minus 2, which is 1, which is 1. 3 comma 1 is up top. So the graph must be looking like this. Just a different way of graphing something you've graphed before. Okay, that's the lesson.